Hello, you're welcome to the Mathematics series with Excellence Simplified, and today I'm going to be taking indices, not just the laws of indices. I'm going to be taking the shortcuts in indices and a lot of past questions using indices. Difficult past questions, we're going to break it down into simple and understandable way, the best way you can understand. All right, so basically, let's do our rapid fire. Let's start with the basic laws of indices before we go into the shortcuts and we start solving. All right, so basically, if you have something like this, if you have a raised to power n times a raised to power n. Now, one thing you should know is that this a here is called the base, while this m here is called the power. So here we have base and power, here base and power. Now, if they are separated by multiplication, notice something here, that the base here is a and the base here is also a. So if the two bases are the same and what is separating them, the sign separating them is multiplication, all you have to do is add the powers. So since the bases are the same, a and a, I took just one a, and since the bases are the same, I took one a, and since it is multiplication, I add the powers. So a raised to power n plus n. That's one law. We're going to see how we apply that and the shortcut for it. The second one, a raised to power m, this thing is divide. So divide by a raised to power n. Now the bases are the same, right? So I'll just take 1. Then since it's division, I will subtract the power. So if it is multiplication, you add the powers. If it is division, you subtract the powers. Now this one, bracket rule. This one states that if you have something like this, you just open the bracket. Now this is a raised to power n, then you close bracket, raised to power another n. So you just use this n to multiply this n. So if you open the bracket, you'll be having mn. So a raised to power mn. Good. Now, this negative inverse law. This negative inverse law states that if you have a negative index, that is, if the power is negative, as you can see, this is a raised to power minus n. To remove this minus, all you need to do is say 1 all over a raised to power n. So to remove minus, I just said 1 all over. Do you understand? That's that. Then the next one here, a raised to power 0 is 1, meaning anything raised to power 0 is 1. 1000 raised to power 0 is 1. 1 million raised to power 0 is 1. Do you understand? Now, next one here, nth root of a equal to 1 a raised to power 1 over n. What does that mean? If I have something like this, a raised to power 1 over n, this is simply the nth root of a. Do you understand? Let me show you something. If you have something like a raised to power 1 over 2, this is simply square root of a. If you have something like a raised to power 2 over 3, this is simply, now, the one that is the denominator becomes the root. So this is cube root of a raised to power 2. Raised to power 2. So this one up here remains where it is. Then the one down as the denominator becomes the root. Don't worry, with examples you understand very well. So let's move on now. All right, so let's look at some examples. Now, example 1 here says example 1 says solve for x. Now you have something like this. If you have an equation like this, the first thing you have to do this. Any equation I'm solving now, they are past questions. I took them from past questions. Now, if you see a equation like this, the first thing you have to do is to smile because this is a bonus question. First, we have 5 raised to power x plus 1 equal to 125 raised to power 2 minus x. All you need to do, I told you about base and power. Your aim at this point is just to make both sides have the same base. 5 here, there is no way we can reduce it again, so we just keep it as 5 raised to power x plus 1 as it is, equal to 125. There's a way we can reduce it. Now you check, 5 raised to power what will give us 125. Why are we using 5? We want them to be in the same base. You agree with me that 5 raised to power 3 will give us 125, right? Because 5 raised to power 3 means 5 times 5 times 5. It will give us 125. So this whole 125 here is 5 raised to power 3. Then we had 2 minus x. This one here. So this 5 raised to power 3 is this one. Why this 2 minus x is this one that was here before. So now I'll be having 5 raised to power x plus 1 equal to 5 raised to power, I open the bracket now, 3 times 2 will give me what? 6 minus 3 times x will give me what? 3x. Good. At this point, you're almost done. If you notice, the bases are the same here. This 5 can cancel this 5. So we'll just take the powers. We just equate the powers. So equating the powers, I will have x plus 1, this one, equals 6 minus 3x. So 6 minus 3x. At this point, I collect like terms. Let x go to one side. The one without x go to one side. This one is with x, so let me bring it here. Minus will change to plus, right? So I'll be having x, this one is coming here, plus 3x equal to 6 was already there. This one is without x, so I take it over. But since it was plus, as it's crossing the equality sign, it's changed towards minus 1, right? Now, x plus 3x will give me what? 4x equal to 6 minus 1 will give me what? 5. Now, to make x the subject of the formula, we divide both sides by what? By 4. So 4 will cancel 4 and x will be equal to 5 over 4. Do you understand? It's very, very simple. Just follow the chain. You just have to make them the same base. You open brackets. After opening the brackets, you equate the powers because the bases will cancel themselves. You equate the powers. After equating the powers, you collect like terms and you are done. You are good to go. All right. So basically, that's the answer to that question. Let's move on to the next question. Now, the next question is looking scary, but don't be afraid. Say simplify this. Now, if you look at this, we have a base here. We have a base here. We have a base here. At the same time, we have power here. We have power here. We have power here. That is the index. All you want to do at this point is there any way we can put all of them in the same base? If we can put them in the same base, then you are good to go. Now check here. 4 here can be reduced to the simplest base. 4 is same thing as 2 raised to power 2, right? So this 4 is now 2 raised to power 2. But now that 4 had a power, that's 3x, right? So this 2 raised to power 2 is so this 4. Now times, want to use different colors so you know which is which. Now times this 8 here, 2 raised to power what will give us 8? 2 times 2, 4, 4 times 2, 8, right? So you agree with me that 2 raised to power 3 will give us 8. But that 8 already had an index. So we will put raised to power x minus 1, right? Now, all over, we are done with the numerator now. The denominator now, we move. This 16, 2 raised to power what will give us 16? 2 times 2, 4. 4 times 2, 8. 8 times 2, what? 16. So you agree with me, 2 raised to power 4 will give us 16. But the 16 already had something on it, so we'll bring it up here. 2x minus 3. Good. At this point, you can continue solving. I want to take it bit by bit until before we enter the shortcut, because at this point you can just do one thing and you get your whole answer. But I want us to take it bit by bit. Now, if you look at this, I can open the bracket. So this will be 2 raised to power. If I open this bracket, 2 times 3x will give me what? 6x times 2 raised to power. If I open the bracket here, I'll be having 3x minus 3 times 1, 3. All over. If I open this bracket, I'll be having 2 raised to power 4 times 2x will give me what? 8x minus 4 times 3, 12. Good. Now remember one of the laws. The bases are the same here, right? So I'll just take 1. Since here is 2 and here is 2, I'll just take 1. Then since it's multiplication, what do I do to the powers? I add the powers, right? So I'll be having 6x plus 3x minus 3. Now all over the denominator here, 2 raised to power 8x minus 12. Now if you check, the bases are the same, 2 and 2, and there's a division line separating them, right? Now in that case, what do? We take just one of the bases, right? So we take just 2 Then raised to power, the numerator now, 6x plus 3x minus 3. Since they are separated by division line, we say minus, right? Is it not? Now, remember, we said that one of the laws states that if the bases are the same and is division, you just take one of the base and you subtract the powers, right? So you'll be having 6x plus 3x minus 3. Then this now minus 8x minus 12, right? Now at this point, if you open the bracket, let me bring it here, you'll be having 2 raised to power 6x plus 3x will give me what? Will give me 9x minus 3 here. Now minus 8x minus 12. At this point, I can freely open my bracket to say 2 raised to power 9x minus 3. This minus here, open this bracket, minus 8x, minus is what? Plus 12, right? So at this point, I'll be having, let me bring it here, 2 raised to power 9x minus 8x will give me what? X, right? Then minus 3, this minus 3 plus 12. Minus 3 plus 12 will give me what? Plus 9, right? They asked us to simplify this, and this is the simplest way we can do that. This is the simplest way we can get this. So basically, this becomes our answer. What did I do here? I just made them the same base. From here, I got my answer. All right. Depending on the option, you know, this is also same thing as saying 2 raised to power x times 2 raised to power 9. So you just check your options very well, because 2 raised to power x times 2 raised to power 9 is, if you want to simplify it, bases are the same, you take one, you add the powers. Basically, that's that. So that is that for that. Moving on to the next one. The next one says simplify this. And here we are having 81 raised to power half times 27 raised to power 2 over 3 all raised to power 1 over 2. This is equation rewritten. Now, if you look at this, I told you in the other law that this is same thing as raised to power half means square root, right? So I can say 81 raised to power half is same thing as saying square root of 81, right? Now times 27 raised to power 2 over 3 is same thing as saying 27 cube root of 27 all square. Remember that law? I told you this one becomes the root, this one becomes the power. Then all of them raised to power half. Now, this is same thing as saying, what's the square root of 81? 9, right? Times, what's the cube root of 27? What's the cube root? Cube root means, what are you multiplying by itself 3 times to give you 27? 3 times 3 times 3 will give us what? 3 times 3, 9. 9 times 3 is what? You've gotten your answer. So here we'll be having 3. But that 3, we have a square on it. So this one gave us 3. Then square is still there. Remember, all raised to power half. This half is still there. Now, we'll be having 9 times 3 square is what? 9. Then all raised to power half again. 9 times 9 at this point is what? 9 times 9 is 81. 81 raised to power half. Now, you know that raised to power half is still our square root. So, this is square root of 81. And square root of 81 is what? 9. That becomes our answer. So, basically, that's what you have to do. Anytime you see raised to power something, this one now, this fraction, the numerator of the index remains as the power. This one that is down here, the denominator, becomes the root. All right. That noted, let's move on. The next question is similar to the one we just finished. And the next question says, if not subscribed to my channel, click on the subscribe button. All right, that's the next question. Moving on, simplify this. This is, if I rewrite this question, I'll be having 9 raised to power minus 1 times 27 raised to power 1 over 3 all over 81 raised to power 3 over 4. Now let's use the principle we just established to solve this. 9 raised to power 1 minus 1. 9 raised to power minus 1 means, okay, let me leave it like this. I have a reason, but you know, this is the same thing as saying 1 over 9 raised to power 1, which is still 9. Remember, if you want to remove minus, you say 1 over, right? But I want to leave it like this for a reason. So here I'll be having 9 raised to power minus 1 times 27 raised to power half means what? Cube root of 27, right? Cube root of 27 all over 81 raised to power 3 over 4 means what? Fourth root of 81 all cube, right? So you'll be having fourth root of 81 then all cube. Remember, this one remains the power, then this one becomes the base, the root. So at this point, I'll be having the numerator, this 9 raised to power minus 1. Let me still leave it like that for a reason. I can't simplify it, but I want to leave it like that. Times cube root of 27 is what? I have it here. All over. Now, to simplify this now, what is the fourth root of 81? What is the fourth root of 81? Now, it's very easy to check. I'll give you shortcuts, but before then, what will you multiply by itself 4 times for you to get 81? So check it out. So let's check it out. If you check that, now, fourth root of 81, let's see, 3 times 3 times 3 times 3. I told you fourth root is what you are multiplying by itself 4 times for you to get that 81. So you can see that 3 is multiplied 4 times. Like by itself 4 times for you to get 81, meaning the fourth root of 81 is what? Is 3. So the denominator here will be having 3 raised to power 3. Now I want to bring all to same base. This 9 here that was leaving 6, you know, 9 is same thing as saying 3 raised to power 2, right? Because 3 times 3 is 9. But we have minus 1 up there. Now times 3 all over 3 raised to power 3. Now this is same thing as saying 3 raised to power 2 times minus 1 is what? Minus 2, right? Now times 3 all over 3 raised to power 3. But you agree with me saying 3 is same thing as say 3 raised to power 1, right? Life is simple. Now, since the bases are the same, I can actually take one base here, the numerator, and say 3 raised to power minus 2. But since it's multiplication, I add plus 1 all over 3 raised to power 3. I'm taking it step by step. When you understand fully, you can jump most of these steps I'm doing. Now this will be 3 raised to power minus 2 plus 1 is what? Minus 1, right? All over 3 raised to power 3. Now the bases are the same of the numerator and denominator, so I take 1. That's 3 raised to power. Since it's division, what do I do to the powers? I subtract. So I'll be having minus 1 minus 3. This will be equal to 3 raised to power. Minus 1 minus 3 is what? Minus 4. That becomes our answer. If you don't want to leave your answer that way, you know that answer there, that's 3 raised to power minus 4 is same thing as saying 1 over 3 raised to power 4, right? So depending on how your option is, you know this is same thing as saying 1 all over 3 raised to power 4 is what? 81, right? 1 over 81. So you just check how the options are, then you take the correct answer. All right, basically that's moving on. If you are watching to this point, the only thing you do is to click on the subscribe button. That will encourage me to drop more videos. And clicking on the subscribe button does not charge, they don't charge you for subscription. Just click on the subscribe button, like this video, drop something in the comment section. At least drop I'm following, drop I'm not following, drop your questions in the comment section and I will attend to them. All right, let's move on to the next question. Next question says evaluate this. So if you have to evaluate 16 raised to power minus 3 over 4, I think this one is a little different from what we've been doing, but still the same principle. Now, if I want to evaluate this, 16 raised to power minus 3 over 4. First thing, let me remove this negative index here. To remove this minus, remember I told you, you say 1 all over, then I have 16 raised to power 3 over 4, right? And remember our power, this will become 1 over 4th root of 16 all raised to power 3, right? This 3 as the numerator will remain. This one as denominator becomes the root. So I'll be having 4th root of 16 all over what? 3. This becomes 1 over 4th root of 16 is what? What will you multiply by itself 4 times for you to get 16? That will be 2, right? 2 times 2 times 2 times 2 give us 16. So we'll be having 2. So everything here becomes 2 raised to power 3. Now this will be 1 over 2 raised to power 3 is what? 2 raised to power 3 is 8. So 1 over 8 becomes our answer. If you don't see it like that in the OBJ, you know that 1 over 8 is same as saying 8 raised to power minus 1, right? Because if you want to change it back, it's still 1 over 8. So anyone you see in the option is correct. Life is simple. All right. Moving on. If you have any question, please drop it in the comment section. I'll attend to them. Next question. Simplify this. This one is very similar to the one we just finished. Let me see who will solve it before me. So as I'm solving, try to solve 2, or you pause and see if your answer was actually correct. Pause and solve. Then you continue the video to see if you got the same answer with me. All right, now the first thing I'm to do is to remove this minus, right? So I'll say 1 over 1 over 27 all raised to power 2 over 3, right? Now this is same thing as saying 1 over cube root of 1 over 27 all square. Now at this point, what are you to do? What's the cube root of 1 over 27? What's the cube root of 1 over 27? If you don't even want to go this way, there's another way you can go about it, but let me allow you to stress yourself this much. What's the cube root of 1 over 27? Alright, so if you look at this, the cube root of 1 over 27 will be, what will you multiply by itself 3 times so you to get 1 over 27? You agree with me that if you say 1 over 3 times 1 over 3 times 1 over 3, you'll get 1 over 27, right? Meaning the cube root of 1 over 27 is 1 over 3. So if I have 1 over 3, we have our square here. I put my square. Now this becomes 1 over, if I open the square, this square is affecting everything, both up and down. So 1 square is 1, all over 3 square is 9. So what I'm having now is 1 all over 1 over 9. And in mathematics, this is, this is 1 divided by 1 over 9, right? And there is a rule that states that if you want to change this division to multiplication, you take the inverse, the reciprocal of the second one, right? So this becomes 1 times, I turn this one upside down, 9 over 1. So the rule states that if you are changing this division to times, you just turn the second one upside down. Simply put, 1 times 9 is 9 over 1. 9 divided by 1 is still 9. So our answer there is 9. Hope you are following. All right, moving on to the next one. Solve 4 raised to power 2x minus 3 equal to 8x. This one is a bonus question now. So all you want to do is let this 4 and this 8 be in the same base. What's the common base you can have? 2. So 2 raised to power 2 will give me 4. But we have something here, 2x minus 3 equal to 8 is the same thing as 2 raised to power 3. We have x there. Now, what do? This base can cancel this base. So I'm having 2 into 2x minus 3 equal to 3x. Now, at this point, I open the brackets here. 2 times 2x will give me what? 4x minus 2 times 3, 6 equals to 3x. 3x. I collect like terms. 4x, this one comes here, minus 3x equal to this one goes there, 6. 4x minus 3x, x equal to what? 6. Hope you understand. That is very, very simple. Alright, let's move on to the next one. Let's move on to the next. Alright, now this one you have to pay great attention. Simplify this. It's similar to what we've been doing. 32 raised to power 4 over 5 means fifth root of 32 all raised to power 4. Fifth root of 32 all raised to power 4. That's what it means now, because I told you the denominator becomes the root, the numerator becomes the power. All over 2 raised to power minus 3. Now what's the fifth root of 32? I can just tell you, but check. The fifth root of 32, what will you multiply 5 times for you to get 32? Check your 2. 2 times 2 times 2 times 2 times 2. That's 2. 5 times will give us 32. Meaning the fifth root of 32 is what? 2. So everything in this bracket becomes 2. We have raised to power 4 all over 2 raised to power minus 3. Since the bases are the same, I take just one. And since it's division, I subtract the power. So 4 minus 3. So this becomes 2 raised to power 4. Minus is what? Plus 3. So I'll be having 2 raised to power 4 plus 3 is what? 4 plus 3 is this. So that becomes our answer. That becomes our answer. 2 raised to power 7 becomes our answer. Simple as that. Alright, moving on. Now I'm solving multiple examples. Now this is our past questions. Why can JAMB past questions? I'm solving multiple examples so that anyone you see, any type you see, you'll be able to solve. So after the end of this video, by the end of this video, you should know that any question on indices is bonus mark for you. Alright, now we're giving another one that is looking somehow here. A raised to power 3x equal to 1 over a raised to power 5. And you're asked to find x. This one is very simple. This a raised to power 3x equals to, you know, this 1 all over a raised to power 5 is same thing as saying a raised to power minus 5. Right? A raised to power minus 5. Remember that rule, that negative index rule. A can cancel a here. So I have 3x equal to minus 5. Making x the subject of the formula, I divide both sides by 3. 3 cancels 3, so x will be equal to minus 5 over 3. Do you understand? Very simple, very simplified, as my name implies. Next question is an assignment. So you are going to do it and drop it in the comment section. For those of you on my JAMB 2026 WhatsApp group, do this. I need the solving, the steps. If you are not on that group, my number is on the screen, so you can chat me up on WhatsApp. I will add you up. That is if you are preparing for JAMB 2026. I will add you up to that group. If you're not preparing for JAMB 2026 and you're just learning this, drop your answer in the comment section. There's no need joining the group if you're not preparing for JAMB 2026. But if you're preparing for JAMB 2026 and you're on that group already, or you're joining that group after this video, all you have to do is solve it step by step. Drop the answer in the group, just like you've been doing. Else, drop the answer in the comment section. And if you've not subscribed, that's the first thing you have to do before you start solving. Click on the subscribe button, like this video, and share to those that we need. See you in my next video. The next video, I'll be treating logarithm. I'll be giving shortcuts in logarithm and sorts. So see you in the next video. My name is Excellent Simplified.